Guys, welcome back. Today we are going to be talking about time travel. I don't know where my pockets are. Oh, time travel. Oh, I guess this guy's all dried out. Let's see if I've got one here. Oh, there we go. See if the red one works too. Red one works. So, we are going to be talking about time travel. And what I'm going to be doing is I'm going to be explaining time travel. And if you're wondering why I'm wearing a spray hood, it's because, I've figured out that there's a lot of crazy people on YouTube, and I'm trying to adapt my look to where I'm less conspicuous in public. Because as my channel gets more popular, people are going to recognize me in public, and I say some crazy stuff sometimes. Nothing that would get me in trouble, just stuff that, some people on YouTube are not going to like. So, anyway, so that's why I wear the spray sock, and I'm not trying to conceal my identity. I'm just trying to make myself less noticeable in public. So, time travel. The first thing we need to know about time travel is humans are one-dimensional beings in time. And what that means specifically is we can only experience the present. So we're one-dimensional beings in time. And my proof for that is all around us all the time. We're one-dimensional beings in time because we can only experience time like this, in an arrow or a ray. I mean, you could have it pointing this way or this way or this way or this way, like that. We could draw it also as a river. Over here on the edge, we could draw a river. We are one-dimensional beings in time. If we were two-dimensional beings, then it wouldn't be like this. There wouldn't be us only observing the president. Oh, the present. We only experience the present. Okay, so that's easy. Now, 2D time travel. 2D time travel. 2D time travel. I'm going to underline that. When we travel in two dimensions of time travel, what we're basically doing, and in my opinion, 2D time travel is the most difficult. So 2D time travel is the most difficult. And why? Why is 2D time travel the most difficult? Well, 2D time travel is basically you're fast forwarding, fast forwarding or rewinding in the same spatial reference, in one spatial reference. And what that means is you're trying to stay put in the same place relative to something else. So if we're talking about Earth, what we're doing is basically I'm standing right here, and time is either fast forwarding, so I'm standing right here, and in 2D time travel, the world is fast forwarding around me, like you've seen in the movie Time Machine. That's 2D time travel. So he's fast forwarding and rewinding through time, and that's 2D time travel, fast forwarding or rewinding in one spatial reference. And in my opinion, that's the most difficult one. And the reason why is because we're sitting here on planet Earth. So we'll draw, here's the sun, and here's the sun just kind of cruising along here. That's the sun. I don't have a marker to make a sun, a yellow one. And then Earth is sitting here cruising around it in a corkscrew like this. And this is Earth. You on Earth. And what makes 2D time travel difficult is 2D time travel is difficult because what you're trying to do is you're trying to stay in the same place and make everything around you go forward or reverse in time. And that's really difficult. So it'd be the equivalent of like making Earth go backwards here relative to us, right? So we're just in the same spatial reference. We're in the same spatial reference, and we're just in one spot relative to Earth, and we're trying to get the sun and Earth and everything to either go fast forward or rewind around us. So it'd be like going backwards, making all this stuff go backwards, the sun and everything, or making the sun and Earth go fast forward. So that's very difficult to do that. And the third kind is 3D time travel. 3-dimensional time travel. And what 3-dimensional time travel is, it's the ability to disappear and reappear I apologize if I spelled appear incorrectly. From time to time, I do spell a word incorrectly. It's the ability to disappear and reappear in any relative spatial reference. My handwriting gets a little sloppier as I get right with my level. So it's the ability to disappear and reappear in any spatial reference. Forgot my L. And what that means is it's almost like magic. And three-dimensional time travel is the second easiest one. And I gotta make sure my microphone's still on, doesn't die on me. Um, Three-dimensional time travel is the second most difficult. The easiest one is one-dimensional time travel. One-dimensional time travel. So we'll erase. I blew my nose on this earlier, but that's okay. It's my whiteboard, right? So we're gonna put time travel up a little higher. Time travel. Time travel. One-dimensional time travel. One dimensional. I'm not trying to make fun of you guys. It's just easier for me to write this out when I'm talking like that. One-dimensional time travel. One-dimensional time travel. And this is the easiest one. Easy. Already doing it. Already doing it. Oops. Already doing it. That's easy. And this one is very hard. Very difficult. And less difficult. So we're getting back to 3D time travel. Three-dimensional time travel is less difficult. Because you're not trying to get your relative spatial reference to move with you. You're not trying to get Earth and the sun and everything to go backwards really fast or forwards really fast, or even slow. That's the great thing about 2D time travel. For certain specific applications, you can slow down time when you're doing 2D time travel. Three-dimensional time travel is not, we're not trying to slow any of these relative spatial references down or up. They're just going about in their one-dimensional form, and we're popping in and out of them. So when we travel in the third dimension of time, we can disappear. So I'd be like, so here I am in the present, and I'm back. And that's the essence of time travel in three dimensions. Now, really, I was just off to the side of the camera. I didn't really disappear into the third dimension of time and then reappear. That's how it works, though, for three-dimensional time travel. And the great thing about three-dimensional time travel is you can disappear and reappear in any relative spatial reference and time. So this is less difficult. And the reason why is what you're doing is through some sort of mechanics that haven't been discovered yet, or maybe they have been discovered and they're just so fringe that I don't know about them. What we're doing is we're traveling through space and time in the third dimension, which for us, we can't see the third dimension of time. We can only perceive the first dimension of time. So we're traveling basically through space and time to these different spatial references, relative spatial reference, and time. It's that simple. So what could we use for three-dimensional time travel? Well, there's all sorts of science fiction and actual theories about this. We could use wormholes. wormhole. We could use time warping, time and space warping. Where we basically take we're basically taking, imagine time. It's that you guys have probably seen a video on YouTube 100 times of this, where you're here. Here's my piece of paper. You're here on this dot, and what we do is we warp space and time, and here's space and time. This paper, space and time. We're warped over, and then boom, we reappear right here. So that would be time and space warping. Wormholes would be the similar thing, where you come in one end of the wormhole, and then you pop out here on the other side of the wormhole in a different spatial reference and time. And there's lots of theories about that. So, in conclusion, what we've discussed today is time travel. I'm not talking about time machines, like how we could build time machines. I do plan to build a time machine. So I will build a time machine. I will build, actually, I'll probably build multiple time machines. Multiple time machines. And we're going to have the kind of time machine, the first kind of time machines that we're going to try for are the three-dimensional time travel machines, because like I said, they're the easiest ones. I mean, relatively. Let's not say easiest, let's say less difficult. The very difficult one, like I said, are the kind from Time Machine, or yeah, movie Time Machine. Time Machine. That's the best way to describe 2D time travel, is through the movie The Time Machine. 3D time travel, like I said, you're talking about wormholes, time and space warping, stuff like that. And it's feasible. So, time travel is, humans are one-dimensional beings in time. And why? Because we only experience the present. So we can do these other ones. Now, that begs the question, can we look into the future and the past? Absolutely. Those are the easiest. And in another video, I'll be discussing how we view the future and past and how that is possible. And I will be explaining it similar to these guys. So that's it. Time Travel Explained by Sean Green. And this, I know I'm the first person to come up with the idea that we are one-dimensional beings in time, because I've looked it up and stuff, and I'm the first one, and that's how it works. And it may sound a little egotistic or whatever. I try not to put my ego in this, because I don't care about the ego. I just want to make stuff. I want to make time machines. Oh, I forgot a period. We're not going to use a period. We're going to use an exclamation point. And you're like, Sean, you're never going to blah, blah, blah. And I'll just tell you, I've made machines. If you look at my channel, when I went to school to be a school teacher, I was making machines that blew the engineers away. The engineering students, they were like gobsmacked and dumbfounded at the machines I would build. I would build these cast metal CNC machines. And I built a bunch of them. And I did all of that while I worked and went to school and everything. And it's nothing to do with ego. I just want to build stuff. And I was hoping to build like a legacy of machines. And then as time goes by, you know, the legacy changes and you evolve and your thought patterns evolve and stuff. And my thought patterns started to evolve into time and time travel. And that's all. If you guys have any ideas about time travel in the two-dimensional form that, you know, might make it to where we could do this, where we stay in the same spatial reference point. So relative, of course. It's always going to be a relative spatial reference. So if you think of a way that we could do that, leave your questions and comments in the comments section. If you think of a way to do three-dimensional time travel, leave your questions and comments in the comments section. My question and comment section isn't for growing the channel or for the accolades. Those are nice though. I like a pat on the back just like everybody else does. My microphone still? Yep, he's still alive. I like those too. What I really like though is when people give me a great idea that I never thought of. So if you guys help me figure out what machines we could use practically to apply these to, that would be awesome in the comments down below. Leave your questions and comments down below.